Today's video will explain the UML component diagram. Hello, I'm James Helfrich. We have many design tools. We have UML class diagrams, we have flowcharts, we have data flow diagrams, we have structure charts. The UML component diagram is unique among these because it's particularly suited to designing large systems. This video will explain how to use the UML component diagram and its individual parts. Component diagrams are design tools allowing for the description of software systems and interfaces of any size or complexity. And here's an example of a fairly typical component diagram, which is a model view controller. Now notice we have the view component, which has two subcomponents, OpenGL and display. We have the controller component, which stands on its own, and the model component, which has two subcomponents, the facade and the database. Now, components are connected by assembly connectors, which look like little lollipops, and oftentimes we name the connection like game or graphics or GLU or SQL. Now, there's an extra little detail here. Sometimes the connection between components has a little square, and that's called a port, and that's a well-defined interface. So this begs the question, when do you use a component diagram? A component diagram is a structural viewpoint, like a structural chart. The only substantial difference between a structure chart and a component diagram is the size of the things they contain. So when you're trying to figure out what viewpoint to use, what design tool, then here's a little decision tree which helps. First of all, are we representing large-scale system design or smaller pieces? So we can go either smaller or large scale. On the smaller side, the next question is, are we describing nouns, verbs, or structure? So we can describe verbs, nouns, or structure. Now, let's say we're describing verbs, what the algorithm does. Then we have another question. Is the challenge the decisions or the loops and equations? It turns out that flowcharts are best for decisions. Now, let's take a look at flowcharts. Flowcharts are for small scale pieces. Flowcharts are best when you're talking about a dozen or a couple, maybe even 100 statements, but not like 10,000 lines of code. Flowcharts are best for verbs that describes algorithms, and flowcharts are particularly well suited for representing decisions. It helps humans visualize them and communicate them to other people. However, if loops and equations are what you're trying to represent, flowcharts do a really poor job of that. There we have pseudocode. Now, just like flowcharts, pseudocode is best for small scale pieces of verbs, namely algorithms, but it optimizes on loops and equations. Now, let's go back up to our second question. Are we describing verbs, nouns, or structure? If we're describing structure, how pieces relate to each other, my next question is the challenge data flow, or how information flows through the algorithm, or how functions call each other? So if it's functions, then we want to use a structure chart. Now, a structure chart is useful for not gigantic things because a structure chart represents just individual functions only, and it's best for the structure, hence the name, or the relative layout of the different pieces. And it's best for how functions call each other, the parameter passing and return values and things like that. However, sometimes what we care about is how data flows through the system, and a data flow diagram is useful for that. Now, let's go back to our are we describing verbs, nouns, and structures question. If the important thing is nouns, namely how data is stored, the things of the application, then a class diagram is perfect for that. Now, a flowchart and a pseudocode did not describe the format of the data. A structure chart and data flow diagram don't describe the format of the data, but class diagrams do. There are other ways to represent nouns too, such as entity relationship diagrams or schemas or things like that. Okay, now let's go all the way back to our very first question. Are we representing a large-scale system design or smaller pieces? If we want to represent a large-scale design, like for an example, the basic layout of a web app like Amazon or Facebook or something like that, then the next question is, are we representing the pieces, the different components, or how data flows through the system? Now, it turns out a data flow diagram is useful for not only describing how data flows through small things like an algorithm or a few hundred lines of code, but as well as very large things. For an example, a web service like Strava or Facebook. If the challenge is not how information flows, but the structure, then we want to say a component diagram. Now we can learn more about the different viewpoints in the viewpoints section of the component diagram chapter of the software design textbook.